And now we return with part 2 of the lesson on the mole. So we'll resume where we left off. Thanks for watching. Of carbon dioxide right there. Okay, a bit of a different example here now. We've got 6 moles of magnesium chloride in a chemical storage container. How many chlorine atoms exist inside that jar? Okay, so this is a question that kind of needs to be done in 2 parts. So first of all, let's find the number of magnesium chloride compound units for 6 moles. Okay, so that's going to be, got my pen here. Sorry, I'm using the wrong thing. Okay, so we're using big N to represent particles. So number of magnesium chloride compound units is equal to 6 moles times 6.02 times 10 to the 23, Avogadro's number. Okay, and that works out to be 3.612 times 10 to the 24 . And in this case, it's compound units. Give myself a little more space here. Okay, so we have compound units. Now, with, there should be a G here. Okay, so with magnesium chloride, for every compound unit, we have 1 magnesium atom and we have 2 chlorine atoms. So, so how many chlorine atoms exist inside that jar? So since magnesium chloride is made up of 2 chlorines and 1 magnesium, what we're going to have to do is we're going to have to multiply the number of compound units by the number 2 here to get the number of chlorine atoms. So we'll just do a quick equation here. So number of chlorines is going to be equal to 2 times number of our compound units, okay, is equal to, and that's just going to be sorry, this is 7.224 times 1024. Okay, atoms. Okay, so in 6 moles of magnesium chloride, there are 7.224 times 10 to the 24 atoms. Okay, moving on to the issue of mass and molar mass, it's called. The carbon-12 isotope, as we've talked about in class, is kind of like the measuring stick for all other atoms. So carbon-12, it's represented like this. Carbon-12 means it's got a total mass of 12. Okay, in other words, it weighs 1 atom weighs 12 atomic mass units. Okay, so that's for 1 atom of the carbon-12 isotope. But if we had 1 mole of carbon-12, that has a mass equal to exactly 12 grams. Okay, and that's the beauty of Avogadro's number. We've got just enough carbon-12 to make up 12 grams of carbon-12. With other elements, the same thing applies. For example, if you have 1 atom of magnesium, you've got a mass of 24.31 atomic mass units. If you have 1 mole of magnesium, then the molar mass, okay, the molar mass of magnesium, we represent it by big M, and the molar mass of magnesium would be 24.31 grams. 1 atom of argon has a mass of 39.95 AMU. Atomic mass units. 1 mole of argon has an atomic mass of 39.95 grams. Okay, etc., etc. Potassium, 1 atom of potassium has a mass of 39.10 AMU, but 1 mole of potassium has a mass of 39.10 grams. Okay, there you have it. So that's one of the important things to know about a mole. Okay, here is a key skill that you're going to need to know how to use, determining the molar mass of a compound. So water, for example, we're going to find the molar mass of water. Okay, we've already talked about how to find the molar mass of a single element. Now, water is made up of 2 hydrogens, and it's also made up of 1 oxygen. Okay, and if we use the periodic table, we can find the molar mass of hydrogen. Okay, so that's going to be, so each hydrogen is going to have a mass of 1.01 grams per mole, and each oxygen is going to have a mass of 16.00 grams per mole. So therefore, put them all together, and okay, give myself a little more space here. The molar mass of H2O, water, is going to be basically 2 times 1.01 grams per mole plus the molar mass of oxygen, 16.00 grams per mole. Okay, add those together and you get 18.02 grams per mole. So that is the mass of 1 mole of water. If you have 6.02 times 10 to the 23 particles of water, they'll have a mass of 18.02 grams. Okay, just to do another example here, we'll work with methane. Find the molar mass of carbon and 4 hydrogens. So the mass of CH4 is equal to, first we'll work with the carbon. Carbon has a mass of, okay, and there's 1 carbon atom in CH4, so 1 times 12.01 is the molar mass for carbon. Add that together with 4 particles of hydrogen, which, as we said before, have a mass of 1.01 grams per mole. Okay, so basically we've got 12.01 plus 4.04. Okay, in total, methane's mass is 16.05 grams per mole. Okay. Another key skill. Once you know the molar mass of a material, you can calculate the number of moles of that substance that you have, or calculate the mass of a given amount or a given number of moles. So let's take a look at this example here. Find the number of moles in 45 grams of water. Okay, Okay, well up here we've just said that 1 mole of water is equal to 18.02 grams per mole. 1 mole is equal to 18.02 grams. So in this case, we've got 45 grams of water. So the number of so I'm going to use the symbol N. Number of moles of water in this case be easy to find. We're just going to divide the mass of the water by the molar mass of the water. Okay, so in this case it's going to be 45 grams divided by molar mass of 18.02 grams per mole. Okay, and when we work that out with a calculator, we get 2.49, I'll just use lots of digits here, 7 moles. Okay, so 45 grams of water is basically 2.497 moles of water. Okay, here we have another question. Find mass of 3.3 moles of methane gas. Okay, so mass of methane, CH4, and we had up here calculated the molar mass of methane. So 1 mole of methane is 16.05 grams. So the mass of 3.3 moles of methane, okay, we'll calculate by going mass is equal to number of moles of methane times its molar mass. Okay, so in this case it's going to be 3.3 moles times, what do we say, 16.05? Grams per mole. Okay, and that equals 52.965 grams. Okay, there we have it. So, in this lesson there have been 2 major relationships just discussed here. If you have a certain number of particles, from that number of particles you can move forward and calculate the number of moles, and you're going to do that by dividing by Avogadro's number, 6.02 times 10 to the 23. If you have a certain number of moles and you're trying to find the number of particles, from that number of moles, you're going to multiply by Avogadro's number. If you have a certain number of moles of a material and you want to know the mass of that material, you're simply going to multiply by the molar mass of that material. And if you have the mass of a given material and you want to know how many moles are in that mass, then you're going to divide by the molar mass of that material. Okay, so now you know the theory behind the mole, and look forward to seeing you in class when we'll try some practice questions. Thanks for watching my video.